All right, so 10.1 is lines, and you probably see that and think, oh, are they just going to talk about the equation of a line? And actually, no, this is lines from a different perspective. We're looking more at lines and angles having to do with lines versus, getting the equation for a line. So it's like you're taking the trig stuff that we just did, and now you're applying some of that angle information or understanding the angle in terms of finding a line. So you can actually find the angle of the line in addition to just the slope. So 10.1 covers finding the inclination of a line, finding the angle between two lines, and then finding the distance between a point and a line. So I'm going to be covering all three of these things. So we're going to start with inclination and slope, and this is actually what you need for the first problem on the assignment. So the inclination of a non-horizontal line is the positive angle that's less than pi measured counterclockwise from the x-axis to the line. So we've got some images here. You're always going counterclockwise, and it's going to be less than pi. So if you have something that's greater than pi, then you're going to measure the angle sort of underneath the horizontal axis. If a non-vertical line has an inclination of theta and the slope is m, then the slope is equal to tangent of the angle. So the key thing here is that slope is not the angle. A lot of people get confused, and I've seen people just automatically assume that slope is the angle. Slope is not the angle. Slope is a tangent of the angle. So that's a key difference there. So we've got this example here. This is number 84 from 10.1. So a moving conveyor rises 1 meter for every 3 meters of horizontal travel. Find the inclination of the conveyor. So the inclination is the measure of the angle. So I'm going to just draw a picture. So our conveyor belt is moving up, and it says that it's rising 1 meter for every 3 meters of horizontal distance. So this creates a triangle, and when we want the inclination, we want to know what this angle is. So we're going to use the fact that the slope is tangent theta. So we have enough information to find the slope. The slope is rise over run, so that's going to be 1 over 3 is tangent of theta. So this goes back to solving trig functions, and we want to take the arctan of 1/3 to get theta. So we take the arctan, or you can write it as tangent to the -1 of 1/3 gives us our angle. So you want to make sure you know what mode your calculator is in. In a situation like this, because it's a real world, we usually have it in degree mode versus radian mode. So I'm going to make sure my calculator is in degree mode, and then I'm going to just take the arctan or inverse tan in my calculator. And so that gives me, for an angle, 18.4 degrees. Now when you're indicating angles, you have to have the degree symbol. If you don't have that degree symbol there, then it is assumed that you are actually talking about radians. So in order to make it clear whether you're using radians or degree, you need to have the degree symbol. So now the second part says the conveyor runs between 2 floors in a factory, and the distance between the floors is 5 meters. Find the length of the conveyor. So again, I'm going to draw a picture. So my conveyor is going there, and it says the distance between the 2 floors is 5. So if I just kind of draw a picture, that is this vertical distance. That is 5 meters there. So the length of the conveyor, that is the hypotenuse if you're making a right triangle here. So we are looking for the length, which is the hypotenuse. So it's not the horizontal length, You got to think about if the conveyor is going at an angle. Now we know what theta is. It's 18.4. So now we're going to use a trig function. We have the opposite side over the hypotenuse, so that's sine. So the sine of theta is opposite, which is 5, over the hypotenuse, which is h. And then when you go to solve for h, you get h is equal to 5 divided by the sine of theta. So we just need to plug in. And since I'm on degree mode, I'm going to make sure I stay on degree mode so that I do the sine of 18.4 degrees. So 5 divided by sine of 18.4. And we get for the height, or not the height, the hypotenuse, the length of the conveyor. I should have used L for length so I didn't get confused. But you get 15.8. So the conveyor is 15.8 meters long. Are there any questions on this example? This is very similar to the kind of thing that you need to do on problem 1. Yeah, it is the hardest thing, and I noticed on problem 1 that the most common mistake is people looking for the wrong part of the triangle. So you want to make sure you draw a picture and label so that you know what you're looking for, because that's what I usually see people get wrong. All right, so next is the angle between two lines. So if you know the angle that are between two different lines, then, or if you know the angle for each of them, the angle of each line, and I've got a picture here, so if you know theta 1 and theta 2, you can find the angle in between them by this complicated looking formula. Now, if we remember that m is the tangent of theta, you can make it simpler by switching all the tangent of thetas to the slope, because the slope is equal to tangent of theta. So if you know the slopes of the line, which is more common, then you can find the angle between them by tangent of theta equals, and then you've got the absolute value of m2 minus m1 over 1 plus m1 times m2. The absolute value is really important, so because in the tangent, it's between, it's only in positive sort of values there. So you want to make sure that if you're finding the angle, you need to have positive values. So example 2, this is number 48 in 10.1. Find the angle between 2x minus y equals 2 and 4x plus 3y equals 24. So I'm going to rewrite the formula that we're going to be using, and we're going to use the formula with the slopes. So we're taking tangent of theta as the absolute value of m2 minus m1 over 1 plus m1 times m2. So in order to use this formula, we need to actually find the slopes of each of those lines, which means putting them in slope-intercept form. So I've got 2x minus y equals 2. So if I subtract the 2x from both sides, we have negative y equals negative 2x plus 2. And then dividing by a negative gives us 2x minus 2. So if this is line 1, then slope 1, m1 is 2, because the slope is the value in front of the x. Now the second line, we have 4x plus 3y equals 24. So if I subtract 4x from both sides, I get 3y equals negative 4x plus 24. And then I'm going to divide everything by 3. So I have y equals negative 4 thirds x plus 24 divided by 3 is 8. So this gives us m2 is equal to negative 4/3. Okay, so now I need to plug these into our equation here. So everywhere I see m2, I'm going to replace it with negative 4/3. So I'm going to have negative 4/3 and m2, negative 4/3. And everywhere I see m1, it's going to be 2. Okay. So now I am going to use my calculator to simplify this in an easier way, because my calculator does fractions. So I'm going to just take advantage of that fact so that I can simplify these fractions. So I'm going to have negative 4/3 minus 2. So that gives me negative 10/3. And then I have 1 plus 2 times negative 4/3. And that gives me negative 5/3. And so the two negatives are going to cancel out, give me a positive, and then we're going to take the absolute value. So I'm going to get a positive. And then we have 10/3 divided by 5/3, which is equal to 2. So this is going to equal 2. So that means we have the tangent of theta equals 2. And then to find the angle, you're going to do arctan or inverse tan, so tangent negative 1 of 2. And you can do it in radians or degree mode here, because this is not, it's not like a real situation, so you don't have to use degrees. You can use either one. My calculator is already in degree mode, so I'm going to just keep it in degree mode. So when I take the inverse tan of 2, that gives me 63.4 degrees. So that is that angle in between those two lines. Are there any questions? All right. Now, the third thing that you cover in 10.1 is the distance between a point and a line. So if you have any point and it's not on the line, and then you have a line, you can find the distance between those. And we always look at the distance perpendicularly, because that is going to be the shortest distance. So I'm not going to be, like if I have my picture, I'm not looking between distance here. It's always going to be perpendicular to the line. So we're looking at the shortest distance between the point and the line. So to use this formula, you have to have your linear equation equal to 0. So you have to put everything on one side so that you can figure out A, B, and C and have the correct signs. So you're basically plugging your point into that equation, or the left side, ignoring the equals 0 part. And then you're taking the absolute value of that, and then you're dividing that by the square root of a squared plus b squared. I'm not going to go into where any of these formulas come from. You can find those when you read the textbook. What's more important is that you know how to use them when you need them. So this is this is number 62. Find the distance between 1, 5 and y equals 4x plus 5. So in order to use this formula, we have everything on the same side. You need to have your equation equal to 0. So it's easier to just move the y to subtract the y from both sides. So that would give me 0 equals 4x minus y plus 5. I'm just putting these in order, x, y, and then the number so that it matches our form. So the form is 0 equals ax plus by equals c. So this gives us that a is equal to 4, B is -1, and C is equal to 5. So now to find the distance between these points, we're going to plug it into our formula. So our formula is D equals absolute value AX1 plus B Y1 plus C over the square root of A squared plus B squared. So I'm going to plug in my numbers. So that's AX1, so that's A times X1. So A is 4, and then X1 is our point. So that's going to be the X value of 1. So that's 4 times 1 plus B, which is -1, times the Y value of 5, and plus C, which is 5. And then we're dividing by our square root of A squared. So that's 4 squared plus B squared, which is -1 squared. So simplifying. On the top, I have 4 minus 5 plus 5. When you do that multiplication, the minus 5 plus 5 cancels, so we just get the absolute value of 4, which comes out to 4. Now in the denominator here, I have 4 squared plus -1 squared, so that's 16 plus 1, so that is the square root of 17. Now, when we have things with square roots in the denominator, we need to rationalize the denominator, and that means that we multiply the top and the bottom by what the square root is. So I'm going to multiply the top and the bottom by the square root of 17. So that gives me D is equal to 4 times the square root of 17 over 17. The square root of 17 times the square root of 17, that cancels out the square roots, you're just left with 17. So you can leave this in its exact form, or if this was a actual word problem with an actual situation, you're more likely to get the decimal approximation. And if you put that in your calculator, and I can just do 4 divided by the square root of 17 in my calculator, because that's equivalent and easier to type in, you get 0.97. Now, there are no units here because this is not a real problem, so we don't have to mention units or anything, but if this was a word problem, you would have to mention your units as well. You want to make sure you keep track of all the units. Are there any questions? All right, so those are the 3 things that you need to know for 10.1. They're easy enough examples. It's all about just using the formula and then making sure you're putting in the right numbers. So this actually was even quicker than I thought. I thought it would take half an hour. It took 20 minutes, 10 minutes quicker than I thought. Do you guys have any questions on anything? You probably haven't started at this week's stuff yet. But if you have any questions on things, let me know. Okay, nothing at the moment. If you do think of something, let me know. As far as the assignment goes, let's see, so problem 1, did an example similar to that in here. Problems 2 and 3, you're going to want to watch the parabola one. Problem 4 is an ellipse. You want to make sure you read that carefully because a lot of people mess up there because they're not reading it carefully, and so they have their points labeled wrong. And then problem 5 is a hyperbola, and there is an example very similar to it in the textbook, but there's not really a lot of explanation there, so I have another example, or I basically took the textbook example and explained it further, and that is in the supplemental materials. So you're going to want to check the supplemental materials for this week, for week 7, to check out that example that will help you with problem 5. And I think that's everything you guys need to know. So if you guys think of anything or you end up having issues, let me know. And I really appreciate that you guys were able to join me live too. And hopefully you guys are staying safe. Hopefully lives aren't disrupted too much. I know that's unfortunately not going to happen. Things are just up in the air, but at least, you know, look on the bright side, try to look positive. Things will get better. They have to get better eventually. You know, things are going to run its course. So just got to hang in there. So, all right. So thank you guys so much, and I will talk to you guys later.